Have you ever really, really, looked at the screen you're using right this second? It starts its life as a simple, kind of boring piece of glass. But in the final moments of its creation, it goes through this radical transformation. Today, we're going to pull back the curtain on those last, absolutely critical steps that turn that glass into the brilliant display right in front of you.
At the heart of it all is this massive engineering puzzle, right? How do you connect a super complex microchip, the actual brain of the display, to a huge, flat sheet of glass with millions and millions of individual pixels? Solving this one problem, well, it's the key to absolutely everything.
So, this whole journey takes place in what the industry calls the back end process. Now, this isn't about making the glass itself. No, this is about everything that happens after the glass is made to turn it into a complete working screen, what's officially known as an LCD module. Think of it like this. The raw glass panel is just a blank canvas. It can't do anything on its own. The back-end process is where it gets all the good stuff. The driver chips, the circuits, the backlight, the frame, literally everything it needs to actually show you an image.
Now, the most delicate, the most crucial part of this entire operation is attaching the electronics. We're talking about connecting these microscopic integrated circuits, or ICs, that are going to tell every single pixel what to do, like 60 times a second or even faster. This stage is known as the JI process. The name comes from the Japanese word for bonding, and that's exactly what it is. It's a series of incredibly precise bonding steps that create that essential link between the data from your phone or computer and the actual pixels on your screen. If you mess this up, you've just got a blank piece of glass.
But here's the thing, this bonding journey isn't a one-size-fits-all kind of deal. Oh no. Depending on whether you're building a massive TV or a tiny little smartphone, the path splits off into two completely different directions. It all really boils down to two main strategies. For big screens like TVs, they use a method called chip-on-film, or COF. But for smaller screens, like in your phone, they use chip-on-glass, or COG. And believe me, which one they choose completely changes the final product, from how it's designed to how much it costs you. So with a huge TV panel, the risk of a tiny defect is really high. So reliability is everything. With the COF method, those tiny driver chips are first put onto a flexible film, kind of like a high-tech ribbon cable. This whole pre-made ribbon is then bonded to the edge of the glass. It's a much more robust process, which means fewer mistakes, but all that extra material and handling makes it more expensive. Now, for your phone, the goals are totally different, right? It's got to be thin, it's got to be light, and it's got to be affordable. So engineers use the COG method. They stick the driver ICs directly onto the glass itself. This saves a ton of space and money, and it's honestly the reason we can have those incredibly slim, sleek phone designs that we all carry around in our pockets. So how in the world do they actually make these connections happen? Whether it's a chip going onto film or a chip going straight onto glass, you can't just use regular solder. No way. The secret ingredient is this amazing piece of material science. It basically acts like a microscopic one-way electrical glue. It's called anisotropic conductive film, or ACF. Yeah, it's a mouthful, but it's for a very, very clever kind of adhesive. It's filled with these tiny little conductive particles. But here's the magic trick. Normally, it's an insulator. It only conducts electricity vertically, straight up and down, when you apply just the right amount of heat and pressure. And the structure is just brilliantly simple. You've got a sticky glue that holds it all together, and floating inside that glue are millions of microscopic little balls coated in conductive metals like nickel and gold. But here's the key. The glue itself keeps all these tiny spheres from touching each other, so it stays insulated. So here's how it works. You take a little strip of this ACF tape and place it between the chip and the glass. Then a heated tool comes down and presses only where the electrical contacts need to be. The little particles in those exact spots get squished together, creating a perfect vertical connection for electricity to flow. And everywhere else, the particles are just left alone, still insulated, which means no short circuits. It's just an incredibly elegant solution to a very tricky problem. All right, so once the brains are connected to the glass using that magic ACF tape, the panel is almost done. The final stage is the module assembly, and this is where all the other pieces come together to create the finished screen that you'd actually recognize. This part is a little more straightforward. First, the backlight. That's the light source for the display.
gets cleaned and checked for any dust. Then the LCD panel is carefully placed right on top. The main control board gets attached, the protective frame or bezel is snapped on, and then the whole thing goes through one last big test to make sure every single pixel is doing its job perfectly.
But here's where we find a really surprising, almost counterintuitive trend. You'd think everything in manufacturing is getting more automated, right? Robots everywhere? Well, for screens, it's not quite that simple. For big TV panels, the assembly lines have actually gone from being fully automatic back to using more human workers. But for small phone screens, the exact opposite is happening. They're moving from manual work to being almost completely automated.
So what on earth is going on here? Well, it all comes down to design trends. You see, modern TVs have these ultra-thin, super delicate frames that are just really hard for a rigid machine to handle without breaking something. They need the gentle, adaptable touch of human hands. On the flip side, that push for borderless, edge-to-edge phone screens requires a level of microscopic precision that, let's be honest, our hands and eyes just can't pull off consistently. So for phones, the robots have totally taken over.
So after all that, what does this actually mean for the device that you're probably holding in your hand right now? Why should any of these manufacturing details matter to you?
Well, first off, that chip-on-glass or COG process is a huge part of why we have thin, light, and pretty affordable smartphones. Second, the incredible precision of that whole JIO bounding process with the ACF film, that's what keeps your screen reliable. When that process fails, that's when you see those awful dead lines or stuck pixels. And finally, the next time you look at a beautiful, borderless display, you'll know it's only possible because of that big shift towards hyper-precise automation.
So that final journey from a simple piece of glass to a brilliant screen is really a story of two different paths, a little bit of material magic and a surprising twist in the world of automation. It's an invisible but truly incredible process that makes our whole digital world possible. And now you know exactly how it works.